Alright, I think this is working. Okay, hey guys, welcome to Industry Scale Models. I have a experiment I want to do with a switch. I've been working on a video with this, and I am going to, well, that's weird, my chat is not in my window here. Let me just get my chat in. Let me try this. Hey Phil, how's it going? Does that work? Well, I have to. Let me try this again here. On my chat, I gotta figure out how to get chat to permanently show up on OBS. I have to apparently copy the URL every time. That seems weird. There we go. You only can stay for 5. Gotta go. Well, you're gonna miss it. This is gonna be pretty cool. I am going to test the battery protection board on the switch. So I am about to set up to test this. I got cables everywhere. This right here, this is the battery protection circuit for the battery of a Nintendo Switch. I have soldered wires to it, and they're about to get hooked up to various meters, and I'm about to inject a signal to this this wire here to see if I can get this to turn on without BQ. So that's my goal right now. So I need to get a couple cables out like this one. This is going to be interesting here. So I'm going to try to get as much of this. Yeah, I can do it without stream elements if I go to view in I can go to view, and then I can add a window, and then I just have to copy the chat URL to the window, and I can get it in my I can get it on OBS. Yeah, you can watch the replay. This could either end really bad or be really cool. So either way, it's going to be interesting. So I don't have a hot air station anymore. That'll be here Tuesday. I'm going to try to get together a live stream on Wednesday morning around this time to unbox it and do a test. Yeah, see, I gotta download. Hey, when you get Stream Elements, does it keep all your stuff in OBS that you had before, or do you gotta reset it all up? Hey, Jaden, how's it going? We're doing an experiment with the Switch here. It could go well, it could go bad. Well, all I know is it's going to be a lot of cables, and I probably shouldn't do it on a stream because it's going to take concentration. But, you know, that's never stopped me before, so this should be fun. So what I got is, I got a, yeah, it keeps it, okay, I'm going to do, when I'm done with this stream, I'm going to check out Stream Elements for this. Right now, I am currently hooking up a pair of banana plugs to my signal generator. I'm hoping that's what I'm doing, but the cable's not wanting to come off. Okay. There it goes. Okay, so for channel 1 of my signal generator, I am plugging in a B and C to banana jack converter. Then I'm plugging these banana jacks into said B and C to banana jack converter. And then I'm going to take these two ends here, and I am going to insert a set of test probes. Set of test probes right here. And we're going to take our set of test probes. I want to go through the whole setup on this because in case someone wants to replicate this, because you don't need the fancy equipment I have, you can do it with a $20 DIY signal generator. You don't need the equipment I have to do this. This is just an experiment to test everything, and if everything works, then all you're going to need to do is inject the signal from the cheapest signal generator you can get, and I actually have something pretty cool coming that will help people with this process. Alright, so let me get the power on the screen here. Yeah, I know you're not. I know you're not streaming, Phil. I'm sad about that because last night I had to leave early. I had a wicked headache. Okay, so we got power. Now we need the. Do we need the meter? No, we don't. We need the load. Where is that at? There it is. I don't use the load software that much, and I have to plug it in. Okay, so hopefully this works. Alright. Okay, so this is getting insane with the stuff I got all over the place. Alright, let me go up here and alright, let me do that, and then let me put that there. I'm just running out of room for all these meters and stuff. I don't need that, but I need the software Easy Wave. Where's Easy Wave? There it is. Okay, so we're trying to open all the software for the signal generator, the power supply, and the electronic load. Yeah, alright, Phil, thank you for stopping by. This should end up being a interesting experiment. It's either gonna fail really bad, or it's going to be pretty cool. Alright, so where did my Easy Wave software go? Okay, so I gotta connect to this. Oh, I can never tell which one it is. Alright. SP. Is it an SPG? SDG? There it is right there. Okay, so we have this window. Easy Wave's not responding. I'm just trying to set up my Easy Wave software here. I guess I can show you what I'm doing. I'm not 100% on this Easy Wave. Let me go here and you guys can see this is the Easy Wave software. What I want to do is I want to send a square wave. Here we go. I want to send a square wave. Alright, let me see. I might be able to pull it from the unit as I program it, so I'm gonna put that there. So I have the electronic load set up, and I have the DC power supply. So we can go back here. We can put on power, and we can put on. I'm gonna have to manually place the load. Okay, so this is a spur of the moment stream, guys. Yeah, this is a spur of the moment stream. is that acting weird? Okay, well, now I have to filters, close. Where is this at? Oh, this is becoming an issue here. Let me. Okay, so I don't know what happened with this. Okay, so this is the electronic load anyways. So we are going to test this battery circuit here very shortly, and I'm going to show you what is the deal. So this is the electronic load. Let's close that. There's our power supply. We need our meter. This is a lot of stuff to get working at one time. So currently I have the battery terminals of the battery board, the battery protection board, on this plugged into the power supply that is currently at 12 volts, but it's going to be put down. It's going to be lowered here as soon as I get this meter set up here. I normally do this before the stream, but I was running late and I thought I could get it done pretty quick. Okay, so we have the protection board. If I take channel 2 on here and I crank this down to 3, let's do 4.2 volts, because that would be battery voltage. So if I take 4.2 volts, the amps it's really not going to make a difference on the amps at the moment. Let me get some probes here. And if I come in here with this and this, and I measure, so you can see I'm putting 4.2 volts onto the battery, and I am going to measure this board here. So I'm going to come over here and put this on here, and I'm measuring across the battery, and I have 0 voltage. And what has happened is I had dropped the voltage on the battery to 2.3 volts, and when I tried to drop it to 2.2 volts, the MOSFET on this circuit here, let me show you what I'm talking about. It is wrapped in Kapton tape for protection for the experiment I'm doing, but I can show you on this camera here, right here under the MOSFET. Right there is is that the BGA chip? Or is that the MOSFET? Hold on, let me see. Yeah, that's the MOSFET right there. So there's the MOSFET. And what has happened is this little U1 chip right here monitors the battery voltage. And what happens is if this detects that the battery voltage drops below 2.3 volts, this MOSFET locks down, clamps it down, and you have 0 output on this power cable. Now, you can see, and I'll turn this off so you can see that the output on the load is 4.2 volts. The load is on, it's drawing 0 amps, and if I come in here and I test this with the right set of probes, I'm not going to get anything again. See, I get no voltage across the battery terminals. of the board. But if I come in here and I stab through the tape there, and I stab through the tape there, you can see I have my 4.2 volts. So I have 4.2 volts going into the board, but I do not have 4.2 volts coming to the battery terminal. And if I touch those, I don't have 4.2 volts. So that MOSFET has locked down. And no matter what I do, I can't get that MOSFET to turn back on. So my theory was that it needs a signal from the BQ chip to unclamp this voltage, this MOSFET on the battery circuit and wake it up, so you could therefore inject voltage and monitor the and then you could inject voltage and charge the battery a little quicker and move forward with your repair. So this is where I'm at, but I was going to hook it up to a whole BQ circuit, but the switch that I was going to hook it up to it has more issues, and I needed to remove some components to make it work. And I got my hot air station went out, so I had to return it, and I had to order a new hot air station. So I have a new hot air station coming. I'm going to unbox it on Wednesday on a stream, hopefully, and I can start working on the switches again. But until then, I am dead in the water on hot air stations, and the switch needs some parts removed so I can test them. So this is where I stand. I'm going to do this test with the injection of a clock pulse and see if I can wake up the battery. Now, plugged into the electronic load is the battery terminal here. So this section right here, I soldered on to this battery terminal connection where it meets the board, and that is plugged into the electronic load. Now, to prove that this is working and I'm not getting any voltage, because you would see voltage on the electronic load, just to prove that to you that there's no voltage, I'm going to unplug it from the load, and I'm going to plug it into this meter that is measuring voltage at the moment, and you'll see that there is no voltage on that. This is why I make my own cables, so I can do this. So if I plug it into the meter, there is absolutely no voltage going through that circuit board. So now the electronic load will read a voltage when it gets a voltage. And in order to do this correctly, I need to not only simulate the voltage of a battery, which is 4.2 volts at this case, I need to also simulate the ability for the battery to absorb current. So it acts like a battery. It can be charged, it can discharge, and I need to simulate that. So I have the power supply connected to the battery terminals for 4.2 volts, and as the input of the battery terminals, I have the electronic load attached to it, so I can set that to 5 volts and about I'm probably going to do 750 milliamps, and then I'm going to set my power supply to 750 milliamps. That way, if it does turn on, the load can handle the pull through the current, because it can charge at 750 milliamps. So I'm not worried about the current consumption. I am going to head and turn the power supply off, and I'm going to get that set up here. So we'll start at 500 and see if that is a thing. So on the load, I want constant voltage. You know what, constant voltage, I guess. Constant voltage, because it won't pull more than the power supply, and it's already set for 5 volts. And if I turn this on, it's drawing absolutely nothing, because there is, even if I turn on the power supply, The power supply is turned on. The load is wanting 5 volts. I don't know if you can see that the load is on. Oh, you know what? I probably didn't connect anything. Hold on, guys. Connect. Okay, why is it doing this to me? Few devices, please wait. Failure to queue. Okay, well there goes the meter. The meter just crashed. Connect to resource, there we go. Please waiting for data initializing. Okay. And do I have connection? No. Okay, yeah, I can turn it on. So we are in constant voltage. Now let me get rid of that. There we go. So now we are on. We are in constant voltage at 5 volts. You can't see that. You're gonna have to trust me. Hey, Crazy, how's it going? Hey, Crazy, I'm testing the battery circuit board to see if I can manually unlock the board with the signal from my signal generator, which could then be in turn done by anybody with a square wave generator. You can build one for less than $20, and you could build it for the sole purpose of this exact pulse that you need. So we have the power supply on. We have the load drawing 5 volts. It can't pull more than 500 milliamps if it kicks on. Let's get the meter back, because we could use that. So yeah, thanks, Crazy. I don't know if that brilliant comment was for me, but thanks. Okay, so you can see that the load is messing around with 1 to 3 microamps. So it is getting a little tingly there. So and the load is not, the power supply is not putting out anything. So let's just check this voltage one more time and make sure that it is dead. Okay, so this is dead. Yeah, that's dead. So let's inject a signal to it. So I want to set this up here. I want to inject a square wave. So I want a mode. No, I don't want a mode. What is? No, I want waveforms, not mod. No, not mod. Waveforms. There we go. I want a square wave. I want I want like 1 hertz. Okay, I got 1 hertz there. Let's go to amplitude. Probably gonna need 5 volts peak to peak. Let's do an offset, and let's bring it up to 2.5 volts. 2.5 volts. So volts DC. Okay, so I have a square wave set for channel 1 at a 5 volts peak to peak, and we're going to do a 50% duty cycle just so, and we're going to burst it. So we're going to burst for 1 second, and for 1 cycle, which is 1 burst, and burst period is 1 second. No, that's not what I want. I want burst period 50 microseconds. What? I can't do 50 microseconds, seriously? What? Why would it even give me an option for microseconds if I can't change the microseconds? That's just odd. Why is this giving me a... No, I don't want that. This is extremely odd here. Why I can't... No, that's the lowest you can go is 1 second. That seems like... Okay. That just seems weird. Let's set the output. Okay, so... Okay, let's turn the output on. We're going to have to check this on the scope. I'm not a huge fan of signal generators this complicated, so we're going to fire up the O-scope to do a test here to make sure this is the wave I want. Because I don't like a 1 second burst, and I'm not sure why I can't get lower than a 1 second burst. But I might go into waveforms and get a pulse. So I need to unhook this temporarily. This is a pain in the butt. Let's hook that up there and output. Okay, what do we get here? That triggered. Oh, we want single. What? What is wrong with this thing? Okay, so where is my threshold voltage at? Edge type, trigger, source, channel 1, not AC line, DC coupling. Let's go up here to about 2.8 volts. Okay, let's go to single, and let's let that arm, and then we'll pop the output on and see what happens. Okay, so okay, that is literally sending a burst out every second. That is literally a burst every second. That is not that's just a lot of noise in that too. Okay, let's see if we can send out a pulse on the waveforms. There we go, a pulse. Okay, so a pulse. Okay, 5 volts peak to peak, pulse width, 200 nanoseconds. There we go. Cycles, 1 cycle. Can I change the burst period? Okay, so I can have it burst every... Let's have it burst every 5 seconds. And... Okay, so we got this set up. Let me plug it in. That would help. Alright, I'm plugging it back into the... So, hopefully plugging it back in. So now, I have a pulse that is going to be sent to this gray wire here, and we are going to go for hoping that this doesn't go bang and I don't... Well, worst that can happen, I can suck 500 milliamps in about a second. So I have this on the gray wire here, and I am going to send a pulse to the battery. Now, what we're hoping to see here is the top meter in the corner read 5 volts and pull 500 milliamps. The power supply to output 500 milliamps, and nothing on the voltmeter because it's frozen. So that is our goal. We'll take the voltmeter off just so it doesn't confuse us. And I am going to send out this output pulse now. And the pulse is going to go. We'll wait one more and get another burst. And okay, so that was basically a clock pulse to a 5-volt clock pulse to the power supply. I want to measure my voltage again just to make sure I didn't trigger it. So that didn't work as I was hoping. I was hoping that burst to the... Yeah, I'm still not getting any voltage. I was hoping that burst to the the chip would have woken it up if it just got any signal. So that did not work. So not any signal to the line will work. So this is going to sound convoluted, but we're going to do some more crazy stuff. So let's see how much crazier I can get here. I don't know how much longer I'm going to let this fiasco go on. If you guys if you guys are getting bored or you're uninterested, you guys can go. I'm not going to hold anybody to this here. This is getting it's getting pretty in depth here. So, but we are going to keep going forward because I want to discover if this is actually a means of activating a battery. And once we activate the battery, then we can do more learning in how the switch works and why things happen. So I am going to hook this, probably not a good idea, BNC to banana jack to my oscilloscope, and then I am going to jump off of these cables from my signal generator to the oscilloscope so we can see the pulse when it happens. So we are going to hopefully not blow anything up. Can we get the scope on the screen? Last time I had this much software running, I could not get it all to work. Can we get the scope on the screen? Let's find out. Alright. Screen capture. Let's do this here. Let's shift. There we go. Let's put that there. Let's go to scope. Screen capture. Can we get this to work? Yes, we can. So, scope on the screen. Scope is on the screen, but it is buried behind something else. And oh, I'm sorry guys. This is normally I would do this on a video, but I am doing it on a live stream for you guys to see. So there is the oscilloscope. That was the square wave that I sent. Let's turn this output off and let's set this up to auto, and let's turn it on, and we should be able to see the pulses. It's milliseconds. Let's see if we can see the pulses here. Let's change the pulse to period to 1 second. Let's change our time scale to 2 seconds. And that should show us our pulses here as soon as it arms. There we go, it triggered. At this slow of a signal, it takes a long time. Okay, so there we go. There are our let's zoom in on one of these pulses. Oh wow. Okay, so why am I not seeing a pulse? Okay, let's put it in single and see if we can just catch an individual pulse. Okay, so let's go out. Can you guys see that on the screen? This little bitty pulse right there. There it is. Okay, so that is the pulse that I sent through there. It is it's still saying it's sent at 4 kilohertz, whatever. Let's put on measure and we'll just measure it. So why is it giving me a peak to peak of 40.4 volts? Are you serious? Okay, let's put on the cursors. So if I go to here and I go to here, so it is about 200 nanoseconds on the X, and if we go to the where do I want? I want measure, no cursors, source channel 1, yeah, that's right. Why can't I get Y? There we go, Y. So if I measure Y here to the top of there, it is, why is it 40 volts? Why is it giving me a 40 volt output on a 5 volt peak to peak? Oh, because I don't have a times 10 probe anymore. So that is directly from the signal. Oh, that's interesting how the scope magnifies that up to 40 volts. That was my issue. So I had the peaks wrong. So that is the pulse that is being sent out on the probes. So I want to, hopefully I turn that output off. Is it off? Or there, now it's off. Okay, so that is the pulse that's being sent. It is, what was it? 203 nanoseconds long. And it's supposed to be 200 nanoseconds, or microseconds. The rising edge. Let's, what can we do now? Let's change. Trying to think. Anybody in chat have an idea of what we can change here? How many viewers do we have? Is anybody even in chat? I probably lost everybody with the crazy talk. Really, it doesn't tell you how many viewers you have? That's just weird. Oh, I don't think I have any viewers right now. 4 viewers at one point. I have 0 viewers now. Okay. So nobody's watching it. Okay. Well, that is the basic principle here. Oh, hey Crazy, how's it going? I thought nobody was here, to be honest with you. Thought I was talking to myself. So the signal from BQ is the key to waking this up. So there is a way. There is a way to look at this. And the fact that I don't have hot air is not going to stop me. I am going to do some crazy stuff right now. We're going to do more crazy stuff to switch number 1 because we're pretty sure that it is beyond hope. So we are going to do some stuff to the switch that is probably not cool, but you know, who cares? We're going to do it anyways. So let's get this switch out of here. So if you're ready for, yeah, it's cool. We're about to do something crazy. So I just need to get this board out of here. This is the one from the last stream that we think possibly could have been hacked in that RCM mode, and I'm looking into that as we speak. But I don't want to get into anything that could possibly be illegal, so I'm taking all the precautions on looking into it. You know what I'm saying? So I am looking into it, and we're going to see if this is fixable. But we are going to, if worst comes to worst, this doesn't work, I have to change BQ, which Phil says that's not fun, but you know, nothing's really fun in life, is it? What is fun? Fun is what you, is a perfect personal preference. I think this is fun. You know, I think a challenge is fun. Okay, so let's put those in the, okay, so we have a switch. We need a charging adapter. Charging lead here. There's our charging lead, and that is going to draw 27 milliamps. It could do something with the battery connected. We're hoping it does, because we are going to hook a battery up to it. Why not? I'm going to hook a battery up to it. Let's do this here, and let's hook a battery up to it and see what we get. So good, it's charging. So what I want to do is I want to I want to plug this ground onto the shell of this thing somehow, or I could just touch ground. And I want to set up my scope for auto. I want to take off measure, take off cursor, off, off, and let's hope this auto sets to what I need. So I am about to probe this gray line on BQ and see what it does. So we are going to see what this does. Oh my god, that is tiny. Okay, so we are going to check this here. What is that doing? So there we go. We got to go. Let's go to 1 volt per division and see what we get. So, okay, so it's about 2.5 volts with a curve to it. So let's single shot it. Let's see what we get. Well, I got instant noise. Okay, so let's single shot again. Let's lower my threshold to about 1.1 volt. Now, see, that's gonna. What's my time delay? Let's do 1 microsecond. Single, and there it goes. Boom, there's my signal. Can you see that? Oh, thank God you can see that. Okay, so let's bring it over here. So that is my signal that is going to BQ. Let's put some measurements on it. It is, should have done this in the first place. So this is, okay, so this is a 12.68 milliseconds of a basic square wave, not a pulse. So it is a square wave, so we're going to go to waveforms, square wave, and we're going to do no, I do think it's more of a pulse. And then we're going to do pulse width. Weird. Okay, I'm just trying to go up to my, to get to the frequency. There we go. So we are doing a waveform, pulse. We're not going to worry about frequency right now. We are going to do pulse width is 12.68 microseconds. Okay. So, and what is the voltage? This is what I do. This is the kind of stuff that I do. That's down at 0 volts. Let's change this to this one. What is that? And that is a pulse. See, this is where I was wrong. It is a pulse of roughly 2.80 volts. Okay, 2.8. Actually, it's saying 2.36. So we're going to do amplitude. There's amplitude 2.36 volts, and then we need a DC offset of this. So the offset is half of 2.36. So 1.150, 60, 70, 80, 1.180 volts DC. So that should give me, it should be directly half of that. Let me just double check that on the calculator because I don't want to mess this up and blow anything. Okay, so 2.360 divided by 2 equals 1.18. Yeah, I got that right. Okay. Yay me for math. Should have used the calculator in the first place. Okay, so now we have the signal we want. I'm going to unplug this, get this garbage out of here. Now, let us go back to this is all still on. Let us send this signal to the if I could find my probes here. Okay. So we are going to send this signal to the battery protection board. And now remember, watch the meters. One should show current and one should show voltage. I will keep an eye on it on my end. If we send the pulse. Okay, the pulse was sent. Take the pulse off and let me just check to make sure everything is on. Everything is on. Let's just check the voltage with the meter real quick. Yeah, we still have nothing. So we sent a exact copy of the pulse. The frequency of that is less than 10 hertz. So I wonder what the actual frequency of that signal is. Let's get this plugged back in and do some more testing. I hope you guys like this troubleshoot testing and figuring things out. I didn't know if this would be an interesting live stream for you guys, or this is how I troubleshoot things. This is a look into my life here of what I do to troubleshoot things. Actually, I want about 200 milliseconds worth of information. Okay, so that triggered. Let's see what we have here. We got a frequency of 29 hertz that time. Oh, my scope is getting slow. Oh, I got too many programs open and it's not letting me do this. Come on, scope. Don't do this to me. See, this is what happens when the scope gets overloaded sending stuff to the screen and you're not even seeing the screen anymore. So let me dump the scope here. Let's refresh it. Does it still say it's connected? It doesn't say it's connected. Let's try it again. Yeah, see, it doesn't want to capture it. Oh, rip scope. Okay, well, the scope has died, so it went bye-bye. Okay. scope has died. Well, my scope hasn't died. The computer software scope has died. So I am going to have to do this manually. Can I now? Yes, I can now. That is... Nope. My scope is still acting weird. So, let's see. Let's change our... Oh, no, let's go back into setup. Let's change... What? Setup. Setup. It's like... Let's go down to 1.8 volts trigger. Trigger on the rising, DC coupling, noise rejection on. And let's go to normal. And let's... Okay, so that's... So we caught that, so let's take a look at what this looks like here. Can I... Wow, that is insane. That's not even... That's just weird. Is this still sending out that charging signal? Huh. That is the strangest thing. It is. Huh. I'm gonna put it in auto and see what it does. See if I get... Yeah, I'm getting this random pulse, but it's at a... It's at 1.1 kilohertz. So... Yeah, 1.07 kilohertz. So frequency 1.07 kilohertz. Yes, I know my heart rate's high, thank you. I'm not a fan of that watch telling me that. Okay, so 1.7 kilohertz, 3.6 volts, or 2.636 volts. So with a pulse width, what was the pulse width on that? Let's go to single mode and let's catch that pulse again. So what's the pulse width on this? Let's zoom in on it. Okay, so let's go to measure. No, measure. Not measure, okay, I want cursor, my bad, X. And it is 12.68 milliseconds. Why did my pulse width 12.68 milliseconds? Okay, it won't let me do a pulse width that wide. The most it'll let me do is 934 nanoseconds. Microseconds. Whatever, I'm gonna try it. So I'm gonna try it at that. This is getting interesting. This is troubleshooting 101 right here. This is what you do. This is how you figure stuff out when they don't give you the data sheets or the schematic. Okay, so let us try to pop a signal in here. And we're gonna let it go for a minute. Pop that, pop it, pop it, pop it. Okay, we're done there. Okay, so that again didn't do anything. Let's just confirm that. Confirmed it. That didn't do anything. So now I'm going to do what I didn't want to do. I am going to plug this into here like so. And we're just going to end this up here, and we're going to plug that into there like that. And see if this recognizes this as a battery. It's not turning it back on. This is interesting. And it's not drawing any current. Very interesting. Am I still getting that same signal from BQ? Oh, of course, I took it off of. I'm still getting that. Yes, I'm still getting that same. No, I'm not. I'm getting a weird signal now. Let me trigger it at one. What? Okay, now I'm getting a weird signal from BQ. So, what am I getting from BQ? Here we go. Let's check it again. Okay, that triggered. I really wish I could have my scope on the screen. Okay, Crazy, thank you. I'm sorry if I missed chat and you said that already. Okay, so let's see what this is. So let's measure this. I really wish I could get whatever the meter on the screen. What is that measuring? So it's sending a pulse 3.42 seconds long. Wow. 3.42 seconds long is what that is sending a pulse to. Because that battery's dead. So BQ's not getting a reading from the battery. So it's sending a 3.42 second pulse to the battery. But it's not telling it to turn on. So everything on my end is good. Let's just check some voltages here. Is the meter working? Yes, it is. Let's check the voltage on this here. And we have 0 volts on there. What is the voltage on the coil? We have 4.3 volts on the coil, but it's not sending a signal to charge this. But it is sending a signal through BQ itself. So that in itself tells us something. That tells us that even if it says it's not charging, BQ is still sending out a signal. An incredibly weird signal, but it's sending out a signal. Let me unplug the charger and plug it back in and see if I can get it to do anything. Yeah, it doesn't want to do anything with that battery, with what I have set up here, even though the battery has got 4.2 volts on it. So I'm going to unhook that and hook up another battery again. So yeah, see, that's charging again. And that pulse, let's check that pulse again with the scope. Let's check the pulse again. Let's go to single. It's going to be a lot different because this is weird. So if I check the BQ triggered, it triggered. Yeah, I probably don't know where it is. There it is right there. There it is right there. So again, if I do my cursor, it's right there at 12 milliseconds. 12.8 milliseconds. 68 hertz, 78 hertz. So let's go to frequency to 78.13 hertz. We want hertz. Now can we change the pulse width to 12.80 milliseconds? Yes, we can change it to that. So now let me take this off of here. Let's try this again with our battery signally thingy here and get my test probes out that I've already bent, which I'm mad about now. Okay, so we're going to put positive on the gray pin and negative on the black pin, and then we're going to pop this pulse on, and nothing. Wow, I can't wake this board up to save my life. I can't wake it up from BQ, and I can't wake it up on my own. So So let's just confirm that we're not getting any voltage out here with the meter, just to make sure. And just for the record, there is voltage going into this battery protection board. Say 3.2 volts going into the battery protection board. So it wants current. See, that's the thing, the load wants 5 volts. Why wasn't the load? It's a two-way line. Well, that makes sense, but something else is in play here. Something else is in play. Does BQ need a signal from the battery? Does it send it something and wait for a packet back? That's the question. Okay. Let me see here. Hold on a second. Okay, here. Okay, so, well, an hour on this testing. So, does the battery somehow generate a pulse? I can't, because it doesn't have any other circuitry. Okay, oh, apparently Phil's coming back, that's good. So, this is very strange. So, we have to look at this a different way now, because this is the part of science that I love. You have a understanding of how something works. You know, you take it apart and you look at it and you take measurements and you assume how something works. And then you test that theory. Like when I dropped the voltage down on this battery and it shut down, That was my theory that that would happen. And then with the data line and the signals coming out of BQ, I formed another theory that BQ would turn this back on. And I'm getting two different signals here. And I wonder if there is some kind of weirdness going on with one of these batteries, that it does some kind of weird signaling or something. I need to find the battery that I took apart and check something when I find it. So, at this point, Phil, I have this. I injected signals from BQ because if I plug in a battery here, a good working battery, and I plug in the charger, it does charge the battery. It does put voltage into the battery. Where's the voltmeter? It's putting voltage into the battery. So it's putting 4.1 volts into the battery, so it is charging the battery on this. But my scope died on the screen, so I can't show you this. But I took the oscilloscope and I measured the pulse coming out of BQ. By measuring the pulse coming out of BQ, I copied its characteristics into the signal generator. And then I proceeded to inject that signal into this board to wake it up. That did jack. That did nothing. So then my next thing was, oh shoot, let's go ahead and screw board number 1 some more and do some more bad things to it. Let's plug it into the power supply with the load attached. And it doesn't even register it. It doesn't even think a battery is connected. And that is completely and utterly odd. Because it doesn't even put out a voltage to said battery. It doesn't even put a voltage to the battery. So when I hooked up the battery, it put 4.1 volts into it. When I hooked up my test rig here, it put no volts into it. So there is way more to this than I had thought. I told you this battery thing was super complicated, and it is very, very strange. It is very strange. So, and now BQ is sending a signal to this unit here, but the signal's freaking weird. It's a 3 millisecond pulse, or a 3-second pulse. What was it? I don't know. My scope could barely capture it, but it was almost a 3-second pulse to the battery. And what I don't understand is the load is set to draw 5 volts at 500 milliamps. So it should be like, okay, thank you, give me the voltage. It should ask to be charged. So there's more to this board than I have been able to figure out. So this has took a turn in a direction I wasn't anticipating. I anticipated that the signal I read from BQ would be present if I hooked up a battery protection board. So might tear a battery. If you tear a battery apart, you get a lithium cell in this protection board. That's all that's in a battery. I tore it completely apart. There is a fuse on the battery, but it is just a straight fuse. There's a fuse here, and I'm getting voltage everywhere I need voltage. That MOSFET will not unclamp. I don't know if I simulated too low of a battery and it just doesn't come back on. But see, here's also the thing. This switchboard is whacked anyways. Yeah, that's what I'm looking to do. This switch was messed up anyways, but I figured it does charge a battery. So I figured it would activate this system here no problem, even though it doesn't turn on and work. And there's no way I'm plugging this dodgy setup into a good working switch that has no problems. Not until I'm more sure about what the battery does. So it's so intermittent that I can't capture multiple bursts on my scope in a reasonable amount of time. I mean, I could set it to a 50-second. What's the longest I could set it for? I mean, I can do a 50-second trigger and maybe capture more than one pulse, but it would take a while. And I don't even know if I would have to copy it. I don't know if I could create that on my generator. Let's arm it. This is going to take a minute. So I saw that picture you sent me, Phil. That looks like some really good steak. That is steak, right? Or was it pork? It looks good, though. This is going to take a minute to arm. It's going to take at least a minute. And hopefully we get it in the one shot. So, yeah, I wasn't expecting the results, but this is what I love about electronics and figuring things out, is you never, sometimes you don't get the results you expect to get. Sometimes it's something totally different, and I expected to copy this signal to my signal generator and then dump it into this board, and this board work like a battery. Yes, steak, sirloin. Yeah, it looks good, man. It looks real good. Yeah, I was expecting this to go through flawlessly, and then I was definitely expecting it when I plugged it onto a working board to turn on, but I wanted to turn it on manually. That didn't work. Putting it to a working charging circuit didn't work either. So it's a very, very odd thing. And I don't know if... See, I've seen batteries lower than 2.3 volts come back. I wonder if I just went so low that it just locked off, and that's it. Once a battery goes that low for safety reasons, they won't let it be recharged. Because that is sometimes an issue with batteries. If they discharge too low and you recharge them, they can have some volatility issues. And I wonder if this protection board is designed, once it reaches a voltage that they feel that it's not safe to recharge the battery again, I wonder if it just shuts down and does not come back. And that's how you have bad batteries. I wonder if it's completely dead permanently. That's a plausible theory. Is this not even armed yet? Oh my god, it's not even armed yet. No. Because it's a system for kids, if the protection board, like for a lithium battery, if you discharge a lithium battery down to 2 volts all the time and recharge it, it can break down some of the inner layers and kind of make little holes in between the layers and the separating layer, and it could not recharge correctly, and it could actually cause damage to the battery, to where if it happens repeatedly, it could catch on fire. That happens with a lot of power banks, a lot of Chinese power banks that are made really cheap, and they don't have the protection circuit in there, and when they discharge down to the 2 volt range and you recharge it, you can the battery could be permanently damaged and ignite, have harmful effects if it goes bad. And I wonder if they designed this to, if it does fall into that best not to recharge it range, it just kills this board. It could blow a fuse. I'm going to check that in a minute. I remember checking them. But it could do something to where it cannot be turned back on. Yes, you could possibly replace the battery circuit. That is not this stream, but that is another stream. But if that is the issue where you replace the battery circuit, if this protection circuit sees less than 2.3 volts, once you pull the battery off, it no longer sees 2.3 volts, and it could lock you out, and you solder the new battery on, and it still won't work. So, yeah, I'm not sure. This is going to take a lot more... Oh my God, this is still not armed yet. This is going to take a lot more research to look into on how this works. What I want to do is, when I get my hot air, I want to pull this MOSFET off and swap it with a MOSFET from another board that has a battery connected, and see if that works. So, that's weird. It is very, very strange. It's still not, I don't think it's going to arm. If you look, can I put this up on the screen here? Yeah, that's fine. If you look here, it's this little 6-pin chip under the Kapton tape that is shut down this MOSFET here. So, I'm not 100% sure. We have a 5 ohm link there, or a 50, and then that's a fuse. There's really not much to this board, of what's going on here. There's literally, I don't think there's anything on the back. Yeah, there's nothing on the back. So, it's very strange. But what was the strangest thing to me was when I hooked this up to this board. Let me turn that off. When I hooked this up to this board, diode and line prevent the charging circuit from charging a button battery. Yeah, that could be a thing. What if that's the case? You might need to supply the voltage to the IC. Yeah, I'm gonna bypass this. I'm gonna bypass this circuit. I'm going to break it. If it's the last thing I do, I'm going to break into this board. This is my new goal. I am going to break into this board and make it work. Because this is crazy, because right now when I plug this charger into it and I connect this to it, I am putting a load of 5 volts and 500 milliamps onto the plus and negative directly, and it won't give it the current. It's asking for the electronic load is asking for that. It's not even registering a voltage. It is asking for 5 volts, 500 milliamps. Let's change it to constant current. Oh, please unlock by shift lock. Oh shit. What is shift lock? There we go. Let's turn it off. Let's go to constant current mode. Let's draw 0.5. No, I don't want 5. Is that going to give me 5 amps? That is. No. 0.5 amps. Okay, let's turn that on and see what happens. No, it doesn't want it then either. So it doesn't want, I'm asking for current. Um, huh. I wonder, what is the resistance across the battery? What is the resistance across the battery? Oh, let's check the resistance across the battery. Oh, I'm not doing that. I don't want to do it with that meter. I don't want to check the resistance across the battery. Let me go back to my current, my voltage. What I need to do is... Oh, wow. Hey, Andy, how's it going? Just watch me F1, so I'm happy. I don't even know what F1 is. I might have to have someone drop in the HDMI job one. Yeah, I don't think I'm gonna be on much longer either, Phil. This is throwing me for a loop here. So I can't. I mean, I am doing nothing but fake this battery. This is essentially the exact battery. This exact battery is hooked up here. So I don't understand what is the issue. There has to be some kind of protection that it just doesn't want to turn back on. I mean, I pumped the same signal back into it that it was giving out. Okay, this thing is ready now, finally. Oh, I need this battery here hooked up. Okay, let's make sure this is on and it's charging. Let's plug this onto there and let's grab this signal. Okay, that's good acquisition. As soon as this is done and I look at it, I am going to get out of here. Hey Zag, how's it going? Yeah, we're just testing the battery circuitry, checking out what happens when the voltage drops below its protection mode, and if it does drop below that protection mode, if I can turn it back on. And so far, no luck turning it back on. So I haven't had any luck turning it back on at all. A bit like that. Oh, Formula One racing. Oh, okay, yeah, I like Formula One racing. Those cars are cool. I'm not a fan of NASCAR though. Yeah, I didn't know that was what. Yeah, Formula One. I got you. So yeah, that's where I'm at. On here, I can't turn this back on, but this is still loading the 50-second signal. I'm going to try this one more time with this signal input here. I want to see what this signal gives me. I don't have any repairs today because I don't have a hot air station at the moment. So this testing of this was going to be in a video. I will release an overview of what I found out, but I'm actually stuck because this is extremely weird situation that I didn't expect. I have seen battery circuits that if a voltage is reached that is low enough, they will shut down and lock out for safety reasons and never come back on. Not even the trickle charge, not even to turn back that on at all. And I'm wondering if dropping that voltage down to that, below that level, if it locked this out completely. But we're going to find out because we're going to have some fun with this MOSFET when I get some hot air. Yeah, hey Zach, how's it going? Yeah, you always getting hit with those same day repairs, Phil. You gotta be like me and just mess with a battery circuit for 2 weeks, trying to figure it out. So this is still acquiring the signal. It triggered, but it's got to load 50 milliseconds of data. I'm using the full memory of the scope at this point. That's why I can't put it on the screen. I am using every last bit of memory on this scope to capture a huge 50-second signal. Inject 30 volts and watch it burn. Yeah, okay. Let's do that. Let's inject 30 volts. Let's go. We'll inject 30 volts. There's 28 volts. It is drawing 500 milliamps. Let's see what we get on the output now. I'll put it back to 4.2. So, it didn't get hot, but what do we have on the output? I actually have a negative voltage on the output now. But there you go. I popped in that, and now it's drawing a half an amp of current. Yeah, I'm not sure on this. All batteries have a dead zone. Not charged. Connect a good battery. Put in charge. Yeah, that's what I'm attempting to do here with my setup. Something similar. Well, now I injected the. I don't think I can't give it 150 watts, Phil. I can do 30 volts at 60 volts at 6.4 amps, but it's drawing 5 amps at the moment. But the board is drawing 5 amps, or 0.5 amps, but I'm not getting any voltage out anywhere. I'm still not getting a voltage through the board. I just basically probably fried the sense resistor on this board when I did that 30 volts thing. Oh, I know I killed it. I don't care. Let's watch what happens when I do this. Yeah, so it's drawing a steady. Yeah, but why is it drawing a half an amp, but not putting out anything? Don't you find that odd? Either this IC is sucking up a half an amp of current, or the MOSFET is, but it's not putting anything out to the output. It's not putting anything out to the output at all. So it's sinking 500 milliamps at 6.2 volts, and it's not getting hot anywhere. Oh, there is a draw connected to it, Andy. There's a DC electronic load. There's a DC electronic load set to draw 500 milliamps connected directly to the battery terminals, and then there is a power supply connected to where the battery connects, and to where the battery connects to the switch is the load. So it is, in all effect, a battery connected to this. Well, not anymore. Now it's shorted out because someone told me to inject 30 volts. But that's alright. That was dead anyways. So, that is that. Yeah, I'm going to check it. It's probably the sense resistor, but I'm not doing that today. I have spent an hour and 30 minutes messing with this and got nowhere. But I did get the signal that the battery gets from the board. I do have that signal, and I copied it. It's on my signal generator at the moment, and I saved it. So I have that signal, and I can use it to try to actually wake up a dead battery when I get one, and see if that works. If my whole system doesn't emulate a battery well enough, I can do it that way. Just inject the signal on my own. But you see, when you have a test battery, you have to double label it. So when it's there, you're good to go. So now, so if it's sitting like this, I know this is my test battery. But if it gets turned over, I still know this is my test battery. You must, at all times, label things. It makes things much easier. And then I have a special drawer that has batteries on it for Nintendo Switches. Not to be confused with my Joy-Cons battery drawer. So that is it. A little bit of label fun at the end. And yeah, I'm at a stopping point for this. I was surprised that I was able to pump 30 volts into that and overwhelm that 32 volt MOSFET, because I would assume that would be a 32 volt MOSFET or a 24 volt MOSFET, and I killed it. No, I didn't label the label maker. The label maker already has a label maker label, so you don't have to label it. Okay. You know what? You have two labels, Phil. Look, here's your two labels right here. It says the coder loves playing with his balls, and then the coder is an a-hole, because we're not going to say the word. And then we will go ahead and make you another label. Here we go, just to make you feel important. And then we will say Phil missed most of the stream. Why won't it press the A button? Stream today. And we'll print yourself your little label, and we'll put it with your other labels to send to you if I get a switch that I pull the CPU off of and need you to reball it. There we go. There's your label. It didn't put the E at the end of the, but you don't deserve it. So there you go. You put it up here with your other labels, and when I get a switch in where the CPU accidentally gets reflowed by hot air, I will send it to you to fix, and I will send your labels with it, along with a nice encouragement label saying you can reball that CPU by hand. So that's going to do it for today's stream. Be sure to check out Phil's channel if you didn't already come from Phil's channel. So this is the coder. He's fantastic. If you did come from Phil's channel, thank you so much. Why is that delayed on there? Yes. You missed the E out. Yeah, I know. You don't deserve the E. You don't get the E. E is for excellent, and you're not excellent. So that's why the E wasn't there. You don't deserve the E. So, yeah, it really, I can sum it up, Zach, that is dead. It did not work. I injected the signal. I injected multiple signals, and I couldn't get the board to turn on. I replicated the signal from a board. It didn't turn on, and then I'm pretty sure it's dead, but I don't have any more bad batteries. All I have is good batteries that I pay $10 a piece for, so I'm not tearing any more batteries apart. But if I get, I plan on getting 5 switches soon from a guy. He has 25. He's going to let me pick through, bring my amp meter and pick through the 5 I want. So, I'm not sure how I'm going to go about it. I was going to say I was going to go for bad USB ports. Let me know. Hey, guys, leave a comment on the video. What kind of switches should I like? What symptoms of a switch should I look for? I got 25 to pick from. What symptoms should I look for to pick the best 5 switches? That's the question. So what do you guys think of that? I got one being tore apart on video, Phil. You don't need to do it. It's not fun disarming a nuclear bomb. And I have you know the battery I took apart was fully charged at 4.2 volts. So if you want to do it, you have to do it at 4.2 volts where it's super dangerous. So I gotta find that battery. It's probably just a ticking time bomb waiting to go off somewhere laying around here. I really don't know what I did with it. Probably should find it. Alright guys, well thank you for joining the stream. Easy fix, EV money with the kind of very similar for YouTube. More for a YouTube, more complicated will be more fun. Yeah, my channel is super complicated. I always get complicated stuff like the one from the stream yesterday. That one was weird, and that wasn't even the one I was gonna work on. I was originally gonna work on the number 3 one that ends up having issues with the MOSFETs, but I can't even do that because I don't have hot air anymore. So you wanna make one? Yeah, take one apart, man. It's fun. When you're done playing with it, send me the board. Where is... I can't find anything. Okay, so I had 5 viewers now. How many viewers do I have now? I have 8 viewers, and it dipped down to 5. I had a max of 8 viewers, and now I have no viewers. Seriously? I just was talking to people. Alright guys, thank you so much for watching. I hope everyone has a fantastic day. And thank you so much for joining. And if you watch this back, leave comments about what you thought about my experiment, if there was a ways I could change it or work on it differently. Thank you guys so much.